Applying the rational root theorem without the use of graphing calculator, we will be given a polynomial function f of x. We'll determine the possible rational zeros and then use polynomial long division to determine a real zero. From there, we'll factor the resulting quotient, then factor the original polynomial function to help us identify all of the roots. We'll do all of that without a graphing calculator, but our last step will be to use a graphing utility to check. Our function is a polynomial function f of x. It's a cubic, raised to the third power, 2x cubed minus 5x squared minus 4x plus 12. Because this is a degree 3 polynomial function, it will have up to 3 real zeros. And the number of turning points, the maximum number of turning points, is 1 less than the degree. So this one will have up to 2 turning points. As far as end behavior goes, it's an odd function, so the ends don't match. My leading coefficient is positive. This one is going to go up on the right end and down on the left end. And I know one point definitely that this function passes through. When I substitute 0 for x, I get 12. So I know my y-intercept is 12. This curve passes through the point 0, 12. But I'm asked to find the x-intercepts, right? The real zeros. So to do that, I'm going to apply the rational zeros theorem, and I'm going to show you how we apply it. We look at our constant term, which is p. List all of the factors of p. We look at our leading coefficient, which is q, and list all of the factors of q. To find the possible rational roots, we do p over q, and we list every number which would work for p over q. So then I start dividing using long division. Synthetic division is not convenient here because of that leading coefficient of 2, so I'll use long division. And I'm going to divide by what I think is the easiest one to try, x minus 1. If I get a remainder of 0, I know that x minus 1 is a factor. If x minus 1 is a factor, then I know that 1 is a root or a 0. All right, so let's start dividing. We ask ourselves the question, x times what is 2x cubed? That would be 2x squared, which I write over the quadratic term. Now multiply 2x squared by both terms in the divisor. I'm going to subtract. To subtract, I like to change my signs and add. And I bring down my negative 4x. Same question, x times what is negative 3x squared? Multiply that negative 3x by both terms. To subtract, I change my signs and I add. Last step of this division problem, x times what is negative 7x? Negative 7x plus 7. I'm going to change my signs and add. I get a remainder of 5. That tells me that x minus 1 is not a factor. Therefore, 1 is not a root. So this curve will not pass through the point 1, 0, but it will pass through the point 1, 5. So if I were sketching this function, I now know another point that I could sketch. Well, for my list of possible rational roots, I tested, is 1 a root? It is not. I can cross that off of my list, and I can try my next possible root to see if, in fact, it is a real 0. This time we'll divide by x plus 1. In doing so, if I get a remainder of 0, negative 1 is a root. So I go through the same process, right? X times what is 2x cubed? I multiply by the binomial terms. To subtract, I change my signs and I add. X times what is negative 7x squared? X times what is 3x? Changing my signs and adding, I get a remainder of 9. I know that x plus 1 is not a factor. Therefore, negative 1 is not a root, and I can cross it off from my list. The curve does not go through the point negative 1, 0, but it does go through negative 1, 9. Okay, so we'll try the next convenient thing to try, I think, would be x minus 2. And we are going to hope that we get a remainder of 0. When we go through the process, it's the same process. I multiply by my binomial terms. I change my signs and I add. X times what is negative 6x, negative 6. I'm going to multiply, then I change my signs and I add, and I get a remainder of 0. So I have found a factor of the original polynomial function. I know by the remainder theorem that x minus 2 is a factor. Now what does that mean in terms of the root? Therefore, I know that 2 is a 0 of this function. I know that this curve passes through the point 2, 0. So where do I go from here? Well, what I'm going to do is take my original function and I'm going to factor it into x minus 2 times that resulting quotient. And I'm noticing that quotient is a trinomial, which I know how to factor using reverse FOIL or the box strategy or something like that. And I'm noticing now that I have a double, I have a factor that I can write to the second power. This tells me that the function f of x has a double root at x equals 2. It also has a root at x equals, so it bounces there. And it has a single root at x equals negative 3/2. Therefore, it crosses through the point negative 3/2, 0. So I believe I have completed the problem. I've found the real zeros. I've given their multiplicities. And I have factored f of x. So now comes the time when we are going to use our graphing calculator and prove that in fact the roots are 2, there's a double root, and negative 3/2 where it will cross. Remember, the left end goes down and the right end goes up, so we're going to type this into desmos, and everything that we said that we determined about this function without a graphing calculator is now verified.